Hello, my name is Dr. Joseph Robles from the Chemistry and Biochemistry Department here at the University of San Diego. Today we're going to talk about how to read the nomogram so you know how fast to spin your centrifuge to get the proper G-force to separate your samples. If you look here, we have two different centrifuges here. We have the F21S, and if you look at the distance from the center to the tubes versus, let's say, the F10S, you have a larger distance. So if these are both spinning at the same speed, the G-force throughout this tube will be different in one centrifuge head versus another head. G-force does not equal RPMs. And also it's important to know if you really have some high-end centrifuge needs that the G-force at the top of the tube and the bottom of the tube are not the same. Because it's at an angle, the distance from the center is different. So oftentimes the calculations are used for average or the middle of the tube. And so each tube, you have to look up how fast to spin this to get the G-force you need. It's not, and when you're reporting your centrifugation, you don't write RPMs. You write G-force. If you do end up writing RPMs, you make sure you say how fast, how many RPMs, and the particular centrifuge head you use. And so it's most appropriate to record the centrifuge and the RPM, the revolutions per minute, how fast your centrifuge was, or it's probably more common just to indicate the G-force that you used when you separated your sample. So let's look at the nomograms. So up here we have three different nomograms. One, and it explains the RPM versus RCF. The G-force is RCF here for the F21. And F14, another centrifuge head we haven't seen yet, but we have available here within the biology department. And the F10. And if you look here at the F10, it says at 1,000 RPM, you have 177 G-force, or RCF, relative centrifugal force. At 6,000 RPMs, you have 6,371. And you can see here for each 1,000 RPM, you can see what the relative G-force is. Also notice on the head and in the nomogram, it tells you how fast your max speed is. Never, never, never exceed that rating. Even if you really need it, you really don't do it. And with older heads, they may need to be derated to a lower speed. And if that's the case, there will be signs indicating. And so for each one of these nomograms, it's pretty straightforward. If you look over here, this is a little more different form, of the nomogram, the force chart. Here on the left, you see the RPMs. And then across each one, it's got the distance from the center. And here we have the SS34, which is 4.25 inches in radius. And then over further is the GSA, or the SH3000. That's the swinging bucket head, which is a little bit larger inch radius from the center of the distance from the center of the centrifuge. And so as you look down here for each one of these, let's say at 2,500 RPMs, for the SS34, that's 755 RCF. And for the swinging bucket rotor, the SH3000, it's 1,020 RCF, or G-force. And so each case, let's say you want a centrifuge down at 2,500 times the force of gravity, or times G, for the SH3000, then go across and find out you need a centrifuge at 4,000 RPM. And so just make sure you're aware of what the max speed is. Always make sure your tubes are balanced across from each other. Your centrifuge is taken care of by being clean. And then you pay attention to the RPM does not equal the G-force, especially as you go from one centrifuge to another. Thank you very much.